Have you ever wondered how Netflix accurately suggests movies you'll like? Or how your email knows how to filter spam? Perhaps you've noticed how your smartphone camera can recognize faces, or how digital assistants like Siri or Alexa seem to understand your commands. These are not feats of magic, but the result of intricate patterns and relationships learned from massive amounts of data. Over time, these systems improve, becoming more accurate and efficient. All these tasks are accomplished with the help of a fascinating field known as machine learning. So, what exactly is machine learning? Well, let's break it down. Machine learning, often abbreviated as ML, is a subdomain of the wider field known as artificial intelligence, or AI. But unlike traditional AI systems that operate based on pre-programmed rules, machine learning systems are a bit more sophisticated. They're designed to learn from data, and over time, they improve their performance without needing explicit programming. Imagine teaching a child how to recognize different types of fruit. You'd show them apples, bananas, and oranges. And over time, they'd start to understand the characteristics that define each fruit. Machine learning works in a similar way. It enables computers to learn from experience, or in this case, data. But the goal isn't just to learn. The true power of machine learning lies in its ability to make predictions and decisions based on new, unseen data. It's like our fruit-savvy child being able to identify a pear for the first time, even though they've never seen one before, simply by applying what they've learned about fruit in general. And just like that child, machine learning models get better with experience. The more data they're exposed to, the better they become at identifying patterns, making accurate predictions, and ultimately making informed decisions. In simpler terms, machine learning is about teaching computers to learn from experience, much like humans do. There are primarily three types of machine learning: supervised, unsupervised, and reinforcement learning. First off, let's talk about supervised learning. Imagine a teacher guiding a student through a lesson, providing them with clear examples of what's right and wrong. That's essentially what happens in supervised learning. The model is provided with labeled examples, or in simpler terms, input-output pairs. It's like saying, "Hey machine, here's what a cat looks like, and here's a dog. Now can you tell them apart?" The goal here is for the model to predict outputs for new, unseen inputs based on what it has learned. Next up, we have unsupervised learning. This is more like a detective's work. The model is given a bunch of data but without any labels. It's like handing over a mixed bag of cats and dogs and saying, "Figure out what's what." The model then identifies patterns, clusters, or structures within the data. It's all about discovering hidden patterns and relationships without any pre-existing labels. Finally, there's reinforcement learning. Think of it as training a dog. You reward it when it does something right, and you correct it when it makes a mistake. Similarly, in reinforcement learning, the model learns by interacting with an environment. It receives feedback in the form of rewards or penalties based on its actions. The model continually improves its performance to maximize the rewards over time. And there you have it: supervised learning, unsupervised learning, and reinforcement learning. Each type has its own unique approach to learning from data and making predictions or decisions. These different learning types allow machines to learn and adapt in various scenarios. Now that we've covered the basics, you might be wondering how machine learning actually works. In a nutshell, machine learning relies on mathematical techniques to detect patterns within data. But how does it do this? Well, it employs various algorithms, which are essentially sets of rules or instructions that a computer follows to solve a problem. These algorithms are not static, though. They are dynamic and change based on the data they are exposed to. This is where the concept of learning comes in. Machine learning algorithms learn by adjusting their internal parameters based on training data to minimize prediction errors. This adjustment process, also known as training, involves the algorithm making predictions and then adjusting its parameters based on how well it predicted. The aim is to reduce the difference between the predicted and actual outcomes. Let's talk about a few common machine learning algorithms. First up, we have decision trees. Imagine a flowchart-like structure where each node represents a feature, each branch represents a decision rule, and each leaf node represents an outcome. The algorithm makes decisions by navigating through the tree based on the feature values, leading to a prediction at the leaf node. Next, we have neural networks. Inspired by the human brain, these algorithms consist of interconnected layers of nodes or neurons. Each neuron applies a simple computation on its inputs and passes the result to the next layer. By adjusting the connections between neurons during training, neural networks can learn complex patterns. Other algorithms include support vector machines. which find the best boundary that separates different classes of data, and K means clustering, which groups similar data points together. Remember, these algorithms are not one-size-fits-all. The choice of algorithm depends on the type of problem, the nature of the data, and the specific requirements of the task at hand. In essence, machine learning is all about finding patterns in data and using those patterns to make predictions. Now, let's explore some applications of machine learning. Machine learning is not just a theoretical concept. It's a practical tool that's already making waves in various domains. Let's take a look at some of them. First, we have natural language processing, or NLP for short. This is where machine learning models process and understand human language. It's the technology that powers chatbots, sentiment analysis, and language translation. For instance, when you chat with a customer service bot or use a translation app, there's an NLP model working behind the scenes. Next, we have computer vision. This is the field that helps computers see and interpret visual information, much like how our eyes do. Machine learning plays a pivotal role here. It aids in image recognition, object detection, and facial recognition. So when your phone's camera identifies your face to unlock the device, that's machine learning in action. Then we have recommendation systems. These are the algorithms that suggest personalized content. When you're scrolling through a streaming platform and it suggests a movie you might like, that's machine learning at work. It's analyzing your past behavior to predict what you might enjoy in the future. In the realm of healthcare, machine learning is a game changer. It aids in disease diagnosis, drug discovery, and personalized treatment plans. For example, machine learning models can analyze medical images to detect signs of diseases, or they can sift through vast amounts of genetic data to aid in drug discovery. Finally, in finance, machine learning models predict stock prices, detect fraud, and optimize trading strategies. They help traders make informed decisions and keep our financial systems secure. As you can see, machine learning has a wide range of applications, and it's playing an increasingly important role in our everyday lives. But wait, aren't artificial intelligence and machine learning the same thing? Well, not quite. It's easy to see why the terms might be used interchangeably, but there is a distinction. Artificial intelligence is an umbrella term. It refers to any system or technology that mimics human intelligence, which can include understanding natural language, recognizing patterns, and making decisions. Machine learning, on the other hand, is a specific subset of AI. It's one way we can achieve artificial intelligence. Machine learning is all about learning from data. Instead of being explicitly programmed to complete a task, machine learning systems learn from the data they're fed, allowing them to make predictions or decisions based on new unseen data. So, while all machine learning is artificial intelligence, not all artificial intelligence uses machine learning. There are other approaches to AI that don't involve learning from data. In short, not all AI uses ML, but all ML is considered AI. Let's summarize what we've learned about machine learning. It's a subdomain of artificial intelligence that empowers systems to learn from data and improve their performance over time. This learning isn't through explicit programming, but by recognizing patterns and relationships in data. We've discussed 3 types of machine learning: supervised learning, where models learn from labeled examples; unsupervised learning, where models identify patterns in unlabeled data; and reinforcement learning, where models learn via interaction with an environment and feedback on their actions. Machine learning works through mathematical techniques that find patterns in data. Algorithms such as decision trees, neural networks, support vector machines, and K means clustering play crucial roles in these processes. The applications of machine learning are vast, from natural language processing and computer vision to recommendation systems and use cases in healthcare and finance. And remember, while all machine learning systems fall under the umbrella of artificial intelligence, not all AI systems use machine learning. Machine learning is a powerful tool that allows computers to learn from data, adapt, and make informed decisions. It's a game changer with applications across various domains.